In this lecture, we will learn more about C and especially about how to make a matrix and lists. And also we will start with the C standard and with some important terms and what they mean for when we write programs. So C has no concept of a multi-dimensional array. Instead we use arrays of arrays. So M, although we informally say that it's, obviously that it's a matrix, but strictly speaking it is an array with 3 elements, where each element has 4 elements. It's an array. So it looks like this in memory. 3 rows and 4 columns, and they are laid out in memory like this. First M00, it's this one, and then they are 1 row at a time. Okay, so it's more efficient to go through 1 row at a time, since we then come to adjacent elements, rather than going through 1 column at a time. Okay, so if we now want to allocate an m times n matrix, and we don't know the value of m and n, what can we do then? We will see that soon, but let's start with a vector. So if we have this type, well, first I should say we cannot create a variable such as, if it would be an array like this and use something with calloc. No, that's absolutely impossible. An array is always a fixed number of elements somewhere in memory that we have already allocated. Okay, so what should we do? We can write A equals calloc n and then the size of each element, size of double. Okay, but how can we do when we have and okay, I should also say, of course, that we can use this as if it was an array. So say this is an array B with some elements, then we cannot see, when we write the source code, there is no difference at all between using a pointer like this or using a real array. But they are allocated completely differently. How can we create the matrix if we need multiple dimensions? We will see that next. But what we do is to use the same number of pointers, levels of pointers, as we need dimensions. So what we can do is to, in this function we want to create and return a matrix. So we start with an array which contains m elements, and we want m rows. Okay, and basically what we will do then is to that line, and then we will let each element in this array point to a row of doubles. So this one has n elements. So here we allocate this n doubles. If we, as I usually recommend, starting with calloc and then if you are certain that you don't need to set the elements to 0 in the beginning, I mean, which calloc does, then one can switch to malloc. And here it's quite clear that all of these elements will be overwritten at once, so there is no point in setting them to zeros using calloc. So here we may prefer to use malloc, and then we have to multiply this ourselves. So the nice thing with using double pointers is that we can use intuitive syntax to get to the elements. And how does this work? Well, it's one pointer redirection at a time. So we can start with this one. Okay, that's unfortunate. Let's call it A of M instead. Okay, so, and A points to this one. So, to get to the element I, we use the first part here and say it's this row, which is I. Okay, and then here is in this is a pointer to n doubles that we allocated there. Okay, and then we find element j in that, using the pointer there and indexing it with j. So it's a two-step way to get to the proper element. It's not perfect. Well, it's more convenient, but it's not always ideal to use this layout, because all these rows will typically be placed in different locations in memory. There is no guarantee that m consecutive calls to calloc will get memory after each other. And instead of calling calloc for each row and the initial array, we can use just one call to calloc. Okay, so we request all the elements at once, use only one pointer level, and then the element size, of course, is double. But now we can't write it like this. And why? Well, that's quite clear. A of I that selects a double in this array. So it will, I mean, it's not the double that we wanted, but it will select a double. So the type of this is double. And then we can't use index if the type is a floating point number, so this is wrong. Okay, so what we have to do is instead to calculate where the rows are ourselves, and then add to get the column number. So what we can do, I'll draw something new, is to divide this into rows. So if we want to get to row I, say it's this one, we multiply I with the number of elements in each row. And then we get to this one, and then we add j. So this is I, and somewhere in there is element j. So this is not a big deal, but if we have a program with numerous array references, this is clearly not as easy to read as this one. And when we write the program, we want it to work correctly as fast as possible, and then we optimize it. Okay.